95.2% accurate. That's what the model said. Sounds good.
It detected zero fraud. Every single case slipped through.
Accuracy didn't lie. It just didn't tell you what you needed to know.
That's what this episode fixes. Episode 16, Model Evaluation Metrics. Confusion Matrix, Precision. Recall, F1, and ROC AUC, the tools that actually tell the truth. Accuracy counts correct predictions over total predictions. That's it.
On a dataset where 95% are non-fraud, predict nothing.
Predict zero fraud on everything. Accuracy, 95%. You just built the worst possible fraud detector with perfect accuracy.
This is why accuracy is the last metric to trust on imbalanced data. The confusion matrix is the foundation. Everything else comes from it.
For cells, two axes, what we predicted and what was actually true. True positive, we said fraud, it was fraud. We caught it.
True negative, we said clean, it was clean. Correct. False positive, we said fraud, it wasn't. A false alarm.
False negative, we said clean, it was fraud. The dangerous one.
That one bottom left cell, FN, is what cost the fraud detector everything. Precision asks, of everything we flagged as positive, how many were real?
TP divided by TP plus FP. That's it.
High precision means your positive predictions are reliable. Low precision means too many false alarms, you're crying wolf.
Precision matters most when false positives are expensive.
Spam filters care about precision. Flagging a real email as spam is costly. Recall asks the opposite. Of all the actual positives, how many did we catch?
TP divided by TP plus FN. Our broken fraud model had recall of 0. Caught nothing.
Low recall means real positives are escaping. You're missing the threat. Recall matters most when false negatives are dangerous.
Cancer screening, fraud detection, security alerts, recall is the one to watch.
Precision and recall pull against each other. Push one up, the other drops. Lower your threshold and you flag more positives, recall goes up.
But you also catch more false alarms, precision goes down.
There's no free lunch. Which one to sacrifice depends on what failure costs.
Fraud. Tolerate false alarms, not missed fraud. Recall wins.
Email spam. Tolerate missed spam, not blocked real mail. Precision wins. F1 is the harmonic mean of precision and recall, both in one number. Harmonic mean punishes extreme imbalances. 1-0 drags F1 to 0.
Our broken model's F1 0. Accuracy was 95. F1 caught the truth.
ROC curve plots true positive rate against false positive rate. Across every possible classification threshold. AUC area under that curve gives you a single number 0.5.
Is a coin flip. 1 is perfect. Our broken model, 0.5.
If this clicked for you, subscribe. Cross-validation is next. In code, Sklern gives you all of this in 2 function calls. Classification_report prints precision, recall, and F1 per class.
ROC curve and ROC AUC score give you the curve and the AUC.
Read the report per class, not just the weighted average at the bottom.
That weighted average is where accuracy hides its lie again.
Let's evaluate the tuned XGBoost from episode 15. Properly this time. Accuracy, 80.4. Same number we celebrated last episode.
But look at the classification report. Class 1 recall, 73%.
27% of actual positives still slipped through. AUC, 0.87. That's actually good, the model ranks well. But recall tells you what accuracy was hiding. Knowing this lets you decide, tune the threshold or collect more data. So how do you pick the right metric for your problem? Balanced classes equal error cost. Accuracy is fine.
Imbalanced classes. Use F1 or look at precision and recall separately.
Ranking models fairly across thresholds. ROC AUC.
When missing a positive is catastrophic, maximize recall directly.
In practice, report all of them. Let the business decide which to optimize. Quick recap before we go.
Accuracy counts right predictions. It lies on imbalanced data.
Confusion Magic, thành phố, FP, FN, TN.
Everything else comes from these four. Precision. How reliable are your positive predictions? Recall, how many actual positives did you catch?
F1. One number that demands both precision and recall are decent.
ROCUC. How well does the model rank positives above negatives? Where are we in the series? We've tuned a model. Now we know how to evaluate it honestly.
Episode 17 is cross-validation, where a single train test split can lie too.
Same data, different split, completely different accuracy. We'll fix that. Episode 17, cross-validation explained. We show why a single train test split gives you a number you can't trust.
K-fold cross-validation, data leakage, and cross_val_score.
Subscribe so you don't miss it.
Your challenge task for this episode.
Create an imbalanced binary dataset, class ratio roughly 9:1. Train two classifiers, one ignoring imbalance, one with class_weight balanced.
Compare them using accuracy, F1, and ROC AUC.
Bonus, plot both ROC curves on the same axis. Annotate each AUC.
Which metric tells the most honest story? Write your answer as a comment.
Full solution is in the repo. Think before you look. Accuracy said 95.2%.
Recall said 0. AUC said coin flip. Now you know which one to believe.
Episode 17 cross-validation drops next. Subscribe. Comment below. Has accuracy lied to you on a real project?